Okay, we are back. Should be set for a bit. Got some questions answered. Now this is going to be, well, we'll deal with committing this code later because it's a little awkward because it's a fork of my own repo. But whatever. So we'll do env. You know what? I can probably save myself a lot of headache if I just go figure out their repo structure real quick. All right, so they've got this. Is this a fork? So this is a fork. Can I fork their fork? No, I can't. All right, so that's going to be kind of awkward because they've kind of vendored a thing, but it's still a fork. So they'll have to give me perms or whatever. Okay. So this should now be play. Well, actually, do this first. We have this line, and then this is play. And then it's, I would have not figured this out, evaluator.policy.uri equals traindir/run name. So 1b. No. Train. Traindir. Let's do it. Maybe. What's wrong with Wanby? My gosh. Let me make sure I didn't mess this up. I didn't comment anything? No, I didn't do anything here. Okay, so what we're gonna do to get this implemented, this is a curriculum algorithm. And we're gonna get working in this other repo. Yeah, here we go. Now we get the diff. So I pretty much should just need to figure out which of these portions need to get added in. Ob shape. Right, so I add this. So I pretty much, I think I can just port this directly. Batch size, BPT, mini batch. Then this is hidden size. And here in experience, hidden size. And then I just need this thing here under values. 3B inverse. And then actually there's very little else to change in clean PufferL, which they've renamed trainer, I suppose. So BPT mini batch policy. Ooh. This should be, I gotta figure out what they did here. So, let's see. Okay, they do have policy. Self.policy.hidden size, like this. And then we'll just leave that as is. And then they should have, this is right here. You put this E3B buffer in. You put this in eval forward. Right here, you get the E3B buffer. This is very similar. Just go like this. We'll have to modify the policy API, which unfortunately theirs is a little bit more fancy than mine is. We'll have to deal with that. But then in trainer.forward, we should be pretty well set. Yep, they have right here. And then all we have to do is we add two new things here that do not matter for training from the policy. And then experience we already handled, so that's it for the whole trainer file. We don't care about these configs, but we do have to deal with the policy API. And I hate this type of thing where you have to add stuff to the policy API. Hey, how's it going? We're adding E3B exploration algorithm into a different repo for some folks. Let me see here. So what do they do for their policy? Because they have a policy store. They have extra stuff though. Quite a bit of extra stuff. I think the easiest way to figure this out is just literally going to be dynamic. So we just put a breakpoint right here. Test, yeah, I see it. Welcome. Works on both platforms. Sometimes some of them have more lag than others, but it should work on both platforms. And I was just given a extra command to try. I'll try that in a second. Watching on X and chatting on Twitch. That's funny. Okay, so this is cool. This actually runs. And you can click on stuff. Looks like the font's a little screwy. But yeah, you can see they're doing some stuff. Oops. If I run train, you're not supposed to give it a URI for train. User warning. Oh, right. Just pushed me a fix for that. Oh, I have to sync my fork. All right. And then this one is going to just be .dot/configs. And then this is just config for now. And then we should be able to do train. All right, so policy, cool. Policy store. Policy store dot policy dot trainer dot initial. Ugh. How about this dot create dot vec_env dot driver env. Okay, you have to go down a little bit here until you get the vec_env. And there we go. So we have only one extra layer. Some extra wrappers, it looks like. We've got recurrent policy of recurrent of puffer agent wrapper. Lots of wrappers. So you have to add E3B to all of this. Unfortunately, the issue here. Unless they pass a config all the way down. But I think even then you still have to do it. Okay. Give me something else. Env. Hang on. Yeah. Getting prototype curriculum algorithm ported to a fork of PufferLib that's mostly PufferLib, has a few things. Okay, so this works. Let me just train. Yeah, no, this is a crazy, crazy week. Like legit 80-hour week, if you include the weekend. This is my fault, so this is. Okay, so we're getting tweaks in from them. In the meantime, I should do Puffer Agent Wrapper. What did we say this was? I guess it's too far up now. I think it was recurrent Puffer Agent Wrapper. So I think I actually have to go into... Well, hold on. This is supposed to be PufferLib, but this doesn't have any of our stuff in it. So where are they getting... Is this... No, this is just one... Okay, wait, this is the recurrent. PufferLib Clean RL. Oh, they have, I guess they have PufferLib installed? Hang on. DevOps. So they clone PufferLib and they build it. And it's their branch. Oh, okay. So they've got PufferLib, like their fork, and then they have some additional PufferLib utils. And probably their fork is going to be way more similar to mine. I wonder what they use from PufferLib actually. If I just cd into metagrid, grep PufferEnv. Well, we don't have to do all this today. I can kind of just give them a quick port of this. Because literally it's just the cleanRL files, I believe. Hold on, what? Oh, no, hold on. Meta. And then DevOps. So they run it from here, they clone it. CD, they stash, they fetch. And then they go, hold on, but then they... Okay, there is a new config. They've been pushing more commits. Thought that's normal. Is not exactly. I don't mind doing it, just as long as I'm not doing it for like sustained very many weeks and, you know, not getting exercise or sleep or whatever. It's kind of fun to work hard in bursts. All right, so. Okay, so they got this. factors. Cool. Next steps. Where's the train command go? This may or may not work with this policy. And then we have to add this. I should be able to do .train on this. Oops. Okay. Oh, shoot. Agent. This is maybe fine. I'm a math student starting to learn RL. What sources do you recommend? Reading intro. Yeah, so that will give you the math heavy version of it. The thing is, there's really not that much crazy math in the RL algorithms that like widely work. I think the hard part for you is going to be more the engineering side. I have a quick start on that. That does include some papers as well. But yeah, the tricky thing in RL, it's a very engineering heavy area of AI. So like we do ultra high performance stuff. These M's are like 1,000 times faster than the majority of what you're going to find out there in academia and most of industry. And it's just because we built them to be fast. If you check here, I'll link this to you. This is my quick start guide for how I recommend people get into RL. It's written more with well, there's some like more mathy papers in there, but it's pretty practical. Yep. You also, I mean, we have a Discord for people who want to get involved with this stuff. Um, there is, to be fair, there is some stuff on the math side that we have for people who are interested in. My own math is pretty weak, so if you want to take a look at some of the stuff I'm doing on that side, I'd be more than happy. I'll link you one cool thing that I'm working on at the moment that's more math heavy. The thing is, there's really not too much of this work at the moment in RL. It's a lot of engineering, but every so often something crops up where it is actually very useful. So I have at the moment an updated version of this algorithm in PufferLib. I've changed some of the way that they're modeling stuff with this. This is a hyperparam sweep algorithm, but the thing that I'm trying to figure out is how to formally model the following process mathematically. So what you want really when you're running experiments, right, you want to uncover the Pareto front. So you want to get a dense set of points along the curve of increasing cost. So you run the experiment for longer and then the score that you can get. And ideally, you know, the longer you run the experiment, the more score you should get. And you want a nice dense set of points along that curve that really tell you how you can do for any level of investment you're willing to put. What I want to do is formulate this process as an overarching optimization process in which you have a total budget of time you're spending on running experiments. And what you want to do is you want to run experiments such that you uncover that curve while minimizing the total time of all the experiments that you're running. So I'm still trying to figure out how to do that portion. But that's like one example of something on the more math heavy side. All right, so they should have PufferLib in here, but I don't see it, which is weird. What's their fork look like? No, they've got a full PufferLib. Git clone. Do they move anything around? I don't see PufferLib. Oh, there it is. All right, so now we get to go look at this. And I just have to change these signatures here. Yeah, so this is just straight up. They haven't even changed this. This is just, this goes here. Uh-oh. Wait. No, it's right here. We're good. And then return 3B and intrinsic. E3B is none. E3B. And we do the same on the recurrent. We do hidden size. And the heck? Oh, this is just E3B. Okay, so that is the clean RL change. We'll need this in models as well. I don't actually know if they use any of our default models. I'll have to go check on that. Puffer agent ramp. So I think that they have their own env agent. Yeah, so they've got their own agent, I think. And let's do grep include star.i. Oops. Agent. And they just use a couple things. They don't seem to use our default policies, so I don't have to modify those at all, which is fine. Simple meta agent, encoder, decoder, so can I put this, let's see, you only really need code observations. I'll need to add this to the, oh, they use TensorDix. So I can just add this to their TensorDict. I might be able to just do this here. No, because this is actually pretty far deep into the wrapper. So I think that the cleanRL interface gets... How the heck does this thing even work? I guess it's their wrapper. Let me see. Puffer agent wrapper. Puffer agent wrapper is here. Did my camera freeze? Let me fix that. They make a TensorDict somewhere? Ah, they do. That's kind of funny. So this thing needs to get E3B'd, I think. Yeah, so it just goes into E3B and then into decode. none, and then this goes into decode. E3B, and we'll just put E3B as E3B. And then this is going to return whatever decode returns, and then decode. I could put it here. Do I even need to go this deep with it? Wait, this is, yeah, no, because it's agent and then meta. So I think I put it here. Value E3B and then intrinsic reward like this. Okay, and then what we do, yeah, this goes in decode. So we can just take this from here actually and do this. And actually, I'll put this up here, value, action, and then this. It's flat hidden dot detach. Intrinsic. And there you go. Yeah, so this should be fine. And I don't think we even need to go any deeper, so we don't even need to mess with their APIs. We just need to mess with ours. Let's see if this works. Probably have to fix some stuff. And what I would like to do actually is put this in my other window so I stop having to tab so much. Can you give me a short rundown of pros, cons? Well, you never run stuff on native Windows. That's just being stupid. You can run it on WSL, which is supposed to have close to native performance and will give you a mostly native Linux environment. Except that then when I went to run my perf tests on that a while ago, it was like down by 25% somehow. I don't even know how they managed to do that. So that pissed me off enough that I just deleted Windows and am running everything on Ubuntu, which has the side effect of having me play fewer games because it is harder to get to most of them. So that is how that works. Why never run? You're trolling if you do any dev on Windows. I mean, if you do any dev on Windows outside of the ecosystems that are clearly designed for Windows, like, you know, you're doing Unity dev or something, you're just trolling. This is just not the operating system for dev, man. Nobody bothers testing their packages against Windows. Half of shit doesn't even work. Like, you're just trolling. You're just wasting your time. You're gonna just waste your time on setup and dumb stuff. Look, the setup that we have at the moment is really, really solid, especially with as bad as the Python tooling is. You dev on either WSL or native Linux in a container. The container has everything set up perfectly, so you have an exact replica of the dev setup in anywhere you're going to dev. It's always going to be the same. If anything goes wrong, you can nuke the container and spin a new one up from the exact, starting point in 5 seconds. It's very, very nice. Dude, yeah, I like do some Linux, man. This is like in terms of like colossal like fuck ups and like colossal fuck ups. This would be more on the colossal fuck ups side of things. Just like the amount of dumb shit that you're gonna waste your time dealing with, like using something that is not a dev platform. Yeah, it's no bueno. Now look, if you already have Windows and you use that just as your standard, just get WSL and you'll be fine. It'll be good enough. It'll give you a native dev environment. Sometimes some of it will drop perf, but it'll be vastly better than anything else, other than like just a native Linux setup. Can't have things break. Okay, well things break. Things are gonna break constantly in Windows. Yeah, don't mess around with dual booting your machine or anything. Then just like WSL. It's probably even pre-installed, or you just WSL dash dash install or something like that. It comes like it's just there with Windows. It's Microsoft's like layer for Windows for Linux compat. Well, you'll have to fix that. I mean, you're like no serious dev work is done like outside of like things like Unity or whatever, where it is literally intended to be done dev on Windows because the target is Windows because it's games or stuff like that. Like just no serious dev is done on Windows, period. Current policy. Okay, so I missed one here. What's up? Currently, we are porting a curriculum learning algorithm to run on a different environment that is part of a somebody's PufferLib fork. Quick little port. And then I think what we're going to probably do if I finish this in not a horrible amount of time is we're going to try to port this maze environment. So we have like a native puffer maze environment because I wanted one for a while and I do not trust the experiments in this repository to give us clear feedback on stuff. Let me, 1 second. All right, decisions that concern me being made without my input that I overheard. So we are just handling that. Let's see. Oh yeah. There's the LSTM as well, which is in PufferLib models. Puffer model. Oops. Where's my LSTM wrapper? There it is. I just missed one. So this is just 3. None. And word, and this is going to just be decode gives you E3B. That's just code E3B. All right, so now I don't have that. Never give you, dude. You gotta have like some sort of conversation there. That WSL is literally like just. That's just like Linux act. I don't know what to tell you. I mean, that's bizarre. I mean, it's bizarre to have parental locks on a 16-year-old in the first place, but I mean, that's a conversation for you and your family, not for me. Evaluator. Oh, hold on. How is this thing? I guess they run this in between. Ah, yeah. I think you just have to add 2 extras to this. Iterate opponent policies. Okay, so luckily I don't think we don't need any of these things at eval time. Only thing we need to do is integrate the intrinsic reward. Okay, that looks to be running. And all we have to do is, where is it? Train underscore about. Yeah, so right here, this is where stuff gets changed for E3B. And then we do, oops. Oh, come on. Okay, so the only other thing we got to do here right here. That's it. This is it right here. This goes right underneath. Right above synchronize, actually. That was close. Let's mess that up. And E3B inv and R. Okay, so I'll add them a flag, obviously, to use this. But here's what we will do. We will, let's just add that flag. Quarks. Config. Figs. Do E3B false. Use E3B. All right, and then we'll do for E3B. If else none. And then we'll just do if. There we go. So we'll try this. And I will make sure that this is getting registered. We gotta sync the fork as well. False. And then let's see if this runs. Should run. Okay, it's running. So I gotta. Oh, come on. How does it, where's the. Oh, I guess it's this breakpoint screwing it up. Okay. So what we'll do is we'll do this. We should pull a config fix first, though. We should pull our config fix. Okay. Alright, so now it's tools train. And then this is going to be, we'll do this will be maze baseline. And then a hardware upper box. And we will see in a moment. uh, that's so funny. We get anything here? Oh wait, error in call. Agent wrapper has no attribute. That's weird that it just spun and didn't exit. No attribute hidden size. Yeah, okay, so we need to fix this one, breakpoint. I forgot about this. More DMs. Good. Comes up and working. Oh, that's funny. That's what kills my camera. It's not drivers, it's the freaking CUDA memory, it looks like. It's like, all right, we don't have memory for this anymore. Because you're running all these neural nets. Error in call. Why would I not want the full stack trace ever, Hydra? Why is this such a shitty config library? It's like, oh no, I don't need the error message. Why would I need an error message to debug my code? Ah, nobody uses those. Alright, no attribute. Instantiate trainer. No attribute hidden size. What? So there's a bunch of Hydra garbage. Instantiate trainer. This isn't code. Fuck off. This is not code. Agent wrapper has no attribute hidden size. I think that I fixed this one now. I think I added this to the recurrent wrapper. And then I think it's RL puffer. Where do I use hidden size? No attribute hidden size. Actor hidden sizes. Who? But I don't know where I even use this. I mean, look at this error message and tell me. Hold on, is it here? Clean RL. Okay, maybe, okay, it's up here, but I don't know why there were 2 blocks of these. If I understand quickly, backprop leaps over some time steps. So should I set it to 1 if every time step contains information for the hidden? So yeah, if you don't actually need recurrence, you can either not use the LSTM, or you can use the LSTM as basically a glorified couple of like linear layers and set that to 1. Usually the correct thing to do is to sweep it, because sometimes that time information can be useful even if you don't require it. Yeah. I mean, it's a nice alternative to frame stacking is the thing. It's usually faster. Like by the time you're frame stacking before or whatever, it's an LSTM can be faster if it's implemented well, which ours is. Changes in the code. So when you train, you have like a mini batch size, right? And we reshape the mini batch into segments. So let's say that you've gotten 128 time steps of data from the first environment. If you set BPT horizon to 16, it will break it up into 8 length 16 segments. And then it will forward pass through those 16 time steps all in parallel across those 8, and then it will backprop through 16 time steps. So it's basically, it's learning over like a context, if you will, of 16 time steps. The reshape is inside of the train function. Let's see if this works. I tried to recalculate. It seems like it's doing leaps on the same index. If it is, then I've dramatically screwed something up, and if that's actually the case and you figure that out, that will be a tremendous help to us. I don't think I did, but if I did, then let me know. Because it should not be doing that. It would be hilarious if we've gotten as good results as we've gotten with it doing that. List index out of range. Dude, I'm confused how the hell this works. Oh, it's decoder outsize. We'll just do this. No, I sometimes screw stuff up. And if nobody actually digs into the code, then it never gets caught. So this is the point of open source right here. Is if you find something, you let me know and we fix it. I already know that our losses are scaled wrong. I screwed that one up. I gotta fix that still. I haven't had any time, but I gotta fix that. That's just like a logging thing, though. That doesn't affect learning. Okay, this seems to run. Maybe. Yes, this runs. So now we just get to do hardware pufferbox. Why are you maxing a leg press? Wait. You gotta be shitting me. Watch this.
Press. Lock it out.
Dude. Alright, we're not taking athletic advice from this guy. We'll buy his supplements, but holy hell, we're not taking athletic advice from this guy. One more time, while we're waiting for the logs to finish. Wait, watch this. This is where it starts. That's the range of motion. Not quite as bad as I originally thought. Still, though, like... That's like barely... That's not even quite parallel, I don't think. Alright. Yeah, no, we're not. Yeah. Alright. Here we are. I don't know why, so this is running training. Not seeing anything here. Some other day you mentioned not state zeroing doesn't make a big difference. Bootstrap, that I have not tested as well. We should be handling in JE. Is there something I'm missing here? I've been told there's something I'm missing here. I thought it was handled in generalized advantage estimation. I have not looked at this in a long time, though, to be fair. So I'll show you where that is. All right, so we have, hang on. So we got clean PufferLib, right? And then we have JE, compute JE. So this gets called right here, and this does actually have duns. I don't think we handle terminals here correctly. We probably should handle terminals here. Yeah, I don't know if, because I'm handling duns, but I don't think I'm handling terminals. So you can take a look at this implementation and see if I'm missing stuff. We'd take a PR on that for sure if it doesn't totally screw up, like add, a loop to it. But here, so we have, where is it? CJE. So here's our generalized advantage estimation right here. Okay, so this runs in C. This is very nice and fast. And you can see we do use, where's the rewards? We do use the duns here to handle terminals for this. Oh yeah, I guess we don't bootstrap the value function across segment bounds. Does that matter? That maybe matters. But like, how do you even do that, right? No, wait, we can do that because you haven't pre-computed without adding another loop. Yeah, I think that could be added to JE actually. I think that's probably missing and should just be added in. I have no idea how much that matters. And I haven't really cared that much because in my mind, JE kind of sucks. JE is one of the things that I actually want to rip out of reinforcement learning completely within the next few months because it adds two hyperparameters, gamma and lambda, which are fundamentally different across environments and even sometimes within like different parts of the same environment. And if they're not correct, then your algorithm cannot work fundamentally. So this prevents you from actually having the same algorithm working on different environments with the same hypers for the most part. And actually, this invalidates multiple different benchmarks. Like if you go look at ProcGen, right, you're supposed to do it with one set of hypers, but actually you can solve all of ProcGen just by tuning per environment PPO parameters because of JE. Because the optimal parameter is like 0.7 in some environments and 0.999 in others. So it's fundamentally impossible to solve with one set of parameters if you have something like this in there. So this is one of the things I hopefully am looking to replace. I don't have any great leads on how I'm going to do that, but in my mind, like we have so many test environments and they're so fast now that once I get a bit more time and I start onboarding a couple more contributors to the science side of Puffer, like we can just run tens of thousands of comprehensive experiments on like new thing we come up with versus old thing, and we will be way, way, way more confident in those results than basically anybody else running experiments in the field because of just the number of different trials we can run on everything. What's up with this? Oh, there it goes. So I don't know what your current situation is, but if you're interested in doing any of this stuff, all sorts of fun things at Puffer. Oops, missed some DMs. Hmm. Found that using slice object is faster. A slice object. Yes, if you index with a tensor, you're making a copy. You're doing a data copy. If you're using a slice, you use a view. If you use the colon index, like 1 through whatever, that's a slice, so that's also a view. Hang on, is this crazy, crazy slow? This might be crazy slow. I'm gonna have to take a quick call for this. A range would work identical to 0. I don't think so. A range is a generator. Wait, are you saying that A range works better? Because that shouldn't be a slice, I don't think. There's an actual slice object that you can make. Like, slice is a keyword. 0:256 should work. Yeah, you would not index with an A range like that. Probably it's going to convert that A range into an array, and then it's going to index with an array, and every time you index with an array, it copies. So that's a redundant copy operation. That's true anytime you index with any array. I think yeah, that's true for any time you index with any array. I mean, you have to think about it, right? Like, it doesn't know that the array is contiguous. Technically, they could build in an optimization to check if the array is contiguous, but that would add overhead, and then it would make it contextual. So, just what they do is every time you give it an array to index, right, they go grab the elements from those indices and copy them. But if you give it a slice, or if you give it, the colon index, which is the same thing as the slice, then it will always